Okay, I'm going to return to my 1001 scripts upon request. I do believe it's getting pretty complex in this series, so I'm definitely there with going through once again. I'm sure I did this at a much earlier stage in another series, ModeLabs data trees at the intermediate level, and I'll be going on to the advanced level as well. I'm sharing their scripts, but they're ones I've generated through it, so there's many, many subtleties and little surprises through here, so please stay tuned. It's hardly theirs, but definitely the ideas are what they're trying to teach and what I'm trying to show again. So let's just jump into here and show basically what I start with. And actually, I'm going to start with the fact that they talk about Weaverbird, GH Python, Kangaroo being awesome. And I thought it would be great to just show an example of Python node. And this is my cousin, my nephew, my son's cousin, that's generating, going through his math program in physics and computer science at the University of Waterloo. And he sent me his quick assignment that he has to do this week. And he sent me the Python script for a spinning top and then bringing it in through Jupyter and then rendering in Matplot library. But I thought, hey, I'll bring it in here, and once I find out how to set the types right and set my input variables and outputs, I'll be able to make this three-dimensionally in possible active top within Rhino. So get your head around GH Python if you want to go there. We'll definitely be going there as we keep creeping along this whole scenario. Anyhow, back to ModeLabs. What they do is they jump in, they grab a script right off the bat, and I'm just going to take a preview on, and they set a color wheel, a new tool to talk about it. They basically build a geometry that your surfaces have total control over what you might want to do with colors and how to gain access to that incredible color wheel by rotating it around, selecting if you want bichromatic, anything you can do with it. It's basically coming from three circles that are internalized in this formula. Very, very simple stuff. We're going to fly through this. The next setup they have, we'll put preview on, is they've set a grid, used a cherry picker tool, which is absolutely an awesome way that I've never thought about gaining access to data, to gaining access into the index count. And what they show is an example of coloring a block to whatever color you want to set it at, as I change that color tone to maybe a yellow, say. Basically, I can move that, hold that on, and we've taken the dispatch and it'll be set to true when it's off, actually, and then you can roll through some of these nodes and you can pick up wherever you want to go, anywhere in that data path, pick and choose. Data structure on a path on different levels of branches you can choose through, and you can pick the exact item number that you want with the cherry picker. Great example, great template. Please get into it and take a look at it. The next script that they show, and I know I go pretty fast on this, but why not? Life isn't short. Or maybe life is too short. They grab a pentagon and then they take it apart at the vertices. And I was showing how I used to call out one of the vertices because it's a closed line, so I didn't repeat it, so I could put a circle at each one and end up with only 6 circles instead of 7. They said, no, just go in, take a shortest list, grab your segments and your vertices, and then plug that into circles, and you'll be left with 6. And they said you could go so far as to make the lines on the internal sides with a cross-reference, and boom, put everything together. Really nice example of that. I've done it in the past, but nothing as clear and straight as what they do within ModeLabs. The next one is an example of going in and having a Sif pattern. And so it's using text data. You're actually back into scripting the way you might think of scripting. Set in your cities, find your pattern, have your true, false, false, or false, true, true, and then put in your replacements under your replacement nulls. A very nice little tool, and you can use it with numbers, geometry, whatever you want. Nice logic and something to use, maybe nodes that I hadn't used before. It's all about the upgrades in Grasshopper that people assume you know anything about, even though nobody's taking you on a tutorial through it. The next thing was another set of cells that has been simplified and grafted in the sake of being able to, and I'll just show you here, which is really nice, totally understand your data in a sense of going through and getting into your tree statistics and using the match tree. For the first time in my life, have I used a match tree, which sets up the paths and sets up the indices in the same format of what you're drawing out of the guide and to your new path. And in doing so, then you get a really nice clean script that you can start to pull. Okay, this is 0, 0, this is 0, 1, go all the way down here, this is 5, 0, 5, 1, and so on. Very nice reading data and just a good practice and good use of that. But once again, tree statistics being used in conjunction with match tree. And they talk about match tree being an incredible tool to start getting into using. That's the first case I think I've ever seen it used outside of seeing the script before. Let's go into here. What was happening here? Let's preview it on. Oh, just a fantastic script. They grab a curve initially, which is a rectangle. They grab a curve to follow. and they take that into those boxes following along that curve. I should take this off so you see what's actually happening. You got a box, you got a curve following along that pattern. Very nice. And then down here they had a rectangular array of using that box and those the object within that box set to that actual rectangle around it. Very nice example of a count on that. And then they do a polar array, which is amazing, but they decided to go into the Kaleidoscope tool, which is just incredible. And then the Kaleidoscope tool paired with divide circle, paired with a Voronoi pattern, and you've got a Kaleidoscope object that's just awesome. And what a script that I know my students will get stuck on and just fall in love with. Wonderful example. Hats off to ModeLabs for kicking butt. Then let's continue. We got 2 more scripts, and I got plenty of time because I love to go fast on these things because the scripts are available on GitHub through M. Wickerson. And, I haven't cut and paste these in any way from ModeLabs. They offer their own. I write these alongside. I change them. I play with them. I put them in different orders. I'm not trying to get credit for them. I'm not trying to make money off them. I'm basically saying, let's take a look at meshes. And what's nice is they put their script out of order in their series and they end with their cluster. But this is one that leads up to that cluster. Grab yourself a mesh. They don't have mesh. You might want to go to display and put mesh edges on so you can see what's going on. You're going to weld the edges, and you'll see the count changes from overlapping meshes to non-overlapping meshes when you do a weld mesh, which is really nice. You're going to evaluate surface just the same way, tied to 4 points that you've allocated around it. Now, I've internalized those points, and you can change them and move them wherever you want. But evaluating surface, mesh surface is the same as evaluating, the mesh closest point is the same as surface closest point, and then a mesh evaluate is the exact same as evaluate surface, except you're dealing with a mesh and not a surface. And then they go so far as to anchor the vectors to it, so you're left with this very nice script that runs through here that you get your points around it, the meshes of which is the closest one on which mesh, and it gives you data to the percentages of what numbered mesh is actually picking up that point. Another great example, they didn't go farther into mesh edges, but if you've done anything in Rhino and you've had to type in show edges to find out if your form is watertight to send to a 3D printer, you're definitely going to want to get into this tool, the mesh edges, to know which is naked, which is interior, and which is non-manifold edges. And if that doesn't make any sense, you obviously haven't tried to take anything to print in Rhino without running into that problem on show edge tools. Almost done. Let's take it out of here and let's go to the last section. They go back in and they say, okay, let's take that mesh and we can, at this point, I believe, take our displays, take our mesh edges off so we're not seeing them. We're going to weld those edges together. We're going to do a color mask on that from these, which is really nice. You take your colors and put it in there, and then say, listen, you can use the spray mesh, because meshes are much better for visualization than NURB surfaces. That's just something they stress. So I brought back up 4 new points. I think there's 4 around there, how they affect the points and how they color it, and then they send through a kind of, not a hoop snake, not through an anomaly loop, but they actually are able to work some iterations on color, which blends those colors really nicely. And you can see how they become stiff and then how they blend. So for visualization tools and meshes, that's great. They go so far as to take that into a cluster. In an earlier video series, they misplace, I think they put it as number 9 in the series they're working on. Just bring that one out and they'll show you how to fine-tune this into an actual cluster and take that to a clustered form. Not going to take the time now to do that. I've done that, or I did do it in an earlier video. You just have to watch that video and do it yourself as you get into clusters. I may do it, I may not. Okay, thanks very much for watching.